Flash is the only superhero able to run faster than the speed of light, or faster than 300,000 kilometers per second. A photon needs 8 minutes to reach Earth from the sun, and our fantastic Flash could win this race by a mile and even have some time to massage his feet before crossing the finish line. And given all the scientific progress that we've achieved, why can't we just do the same? In this video, you'll find out why is it incredibly hard to catch up with a photon in the literal sense? How can we make a spacecraft travel faster than light? And can we eventually break this constant? Albert Einstein's special theory of relativity says that the speed of light is the maximum speed at which something can move around the universe, period. And yet, there are exceptions to every, even the most hard and fast rule, right? These particles located next to each other are entangled. But even if they break up and move to the opposite corners of the universe, they'll still be connected by an invisible umbilical cord. And when one particle's condition changes, the other will immediately feel it. And when I say immediately, I mean faster than the speed of light. Einstein was a harsh critic of quantum entanglement, as it apparently challenged his theory. However, it won't help us much if we want to break the speed of light, since in this case, it's not a particle that actually moves, but only a bit of information about it. Another thing is, if the particle decided to board a wormhole like in Interstellar, this is a hypothetical hole in spacetime, or like filmmakers usually visualize it, on a map folded in half. Let's imagine that the entrance to the wormhole lies near Earth and the exit lies close to the Sun. It's not that far, but if anything leaps between the first and the second point in an instant, that would happen 500 times faster than the speed of light. Here are a few problems, though. According to physicists, everything that travels through a wormhole absorbs a large and dangerous dose of radiation. Besides, such tunnels are treacherous. Just stick your hand in there and you'll face a massive explosion compared to that of a supernova. Although some explosions can be even helpful. These are gamma-ray bursts occurring when two neutron stars merge into one. The bursts are so powerful that the radiation waves inside the plasma jets can go faster than light. Now, do you think we found a way to get what we want? Not so fast. 300,000 kilometers per second is the speed of light in a vacuum, but it can be substantially lower in any other environment. Normally, photons travel 1/4 slower than that, and plasma jets seen during gamma-ray bursts don't have anything to do with a vacuum. This means that even though the radiation waves are faster than sluggish photons, they still can't reach 300,000 kilometers per second. Oh, so close. Come on, scientists, can't you just think a bit harder and finally break the speed of light? How exactly are scientists trying to break the speed of light? In the mid-90s, physicist Sergei Krasnikov said that faster-than-light journeys are real. We need to build a special spacecraft first, and then lay tubes in the warped spacetime. The idea is, in fact, creating wormholes home version. The main thing minus radiation and sudden explosions. In theory, they'll let us get from one point on the world map to another in a jiffy. No exaggeration. However, so far, we can neither create an interdimensional auger nor accelerate the first tunnel paver to the speed of light, or at least close to it as required by Krasnikov's plan. Fortunately, there are more realistic technologies that attracted NASA's attention. In 1994, Mexican physicist Miguel Alcubierre was watching Star Trek when he had a light bulb moment. In that show, the Enterprise starship uses a warp drive that can break the speed of light by curving spacetime. And that's not science fiction at all. Many distant galaxies really move away from us faster than light, Not because they're so fast, but because the space between them doesn't seem to care about Einstein and his theories, and can expand at superluminal speed. Alcubierre used this trick in his project. Alcubierre warp drive contracts space-time in front of the spacecraft while expanding it behind the ship in a special way. Different pressures create a wave that lets it accelerate as much as needed so it can easily break the speed of light. That's like surfing. Catch some truly big wave, and you'll easily beat all the slowpokes. There's only one trouble. Alcubierre warp drive requires a lot of negative energy to speed up. No, I'm not talking about the tension you feel when your ex enters the bar with a new partner. This is a hypothetical and currently fantastic form of energy that no one has ever seen. But let's imagine we found it. What then? Can we finally break the speed of light? Even in this case, there are lots of problems waiting around the corner. What will happen if we find a way to get close to the speed of light? When accelerating, we'll fall into a trap that Albert Einstein also warned us about. This guy is such a buzzkill. He does everything to ruin our plans. Let's put a stout 2-month-old kitten weighing 1 kilogram in a rocket. When it reaches 1/5 of the speed of light, our cutie will become 20 grams heavier. Can it be just because of the stress? But when the spacecraft breaks 90% of the speed of light, the kitty will be twice as heavy. Einstein told us that the faster an object moves, the harder it is to actually move. This mass is called relativistic, and it derives from the increasing energy that the kitten produces while accelerating. And the closer a body gets to the speed of light, the harder it is to go even faster. When it nearly reaches the light barrier, the kitty's mass will start approaching infinity. It's impossible to build a rocket that won't fall to pieces carrying even one little baby like that on board. Then why doesn't Flash turn into Jabba while running, but stays a fit and robust athlete? There can be only one scientific explanation. Meet Lighthack, a hero with a purely scientific superpower. He controls negative energy to make his body have a negative mass to compensate for the subsequent weight increase. Will everything work out now? When he reaches 90% of the speed of light, Lighthack will notice time as if it slowed down. That's another relativistic effect that was explained by Einstein. What's more, Lighthack will look at the world as if through a tunnel. At 99% of the speed of light, the picture will get almost impenetrable. No, it doesn't mean that our superhero goes blind. The thing is, the photons that hit his eyes go beyond the visible spectrum, and as soon as he breaks the speed of light, time around Lighthack will stop, and he'll be engulfed in eternal darkness. Now, our boy knows what it's like to be a photon, but what if he's so incredibly strong that he can overcome the last barrier? What kind of side effects will you have to experience if you break the speed of light? As we remember, Lighthack has a superpower and can balance out his infinite mass. However, if he loses focus and stops using his super ability for even a millisecond when already moving faster than light, Lighthack's foot will slam into the asphalt with infinite power. The whole stadium will explode, and the asteroid strike that killed dinosaurs will seem like a sneeze compared to that. Since we don't want our Earth to be wiped out of existence, let's send Lighthack running in a cosmic vacuum. But that in turn will get the whole universe in trouble. Because according to Einstein's theory, time itself will collapse at the superluminal speed. After breaking the warp barrier, Lighthack will discover that everything around him now goes backward. And theoretically, he'd be able to run and catch up with himself on Earth at the moment he started his race. Although I'm not quite sure that our hero will live to experience this paradox. That's because all the photons outrun by Lighthack aren't only light particles. They're also a part of chemical reactions between atoms and molecules. And all this stuff is done at 300,000 kilometers per second. When Lighthack's pace dramatically exceeds the speed of light, he'll become too fast to interact with any kind of photons. In other words, he'll be totally invisible to us. At the same time, breaking the speed of light and defeating photons will strip atoms in Lighthack's body of the capacity to form chemical bonds. Our hero will cease to exist as one being. He'll either turn into a cloud of dust or explode with the force of 100 atomic bombs, or both things simultaneously. Ouch! Why doesn't this bold idea of breaking the speed of light do any good? Why does it only create problems? Einstein's followers have the answer. 300,000 kilometers per second isn't only the speed of light, that's also the maximum speed of any possible interaction in our universe. That's the constant encrypted in the very essence of our world. If we try to meddle or challenge it, the universe won't stand by and watch. It'll destroy us all in response. But suppose you're still eager to break the superluminal speed. In that case, devoted fans of the multiverse theory will suggest you try your luck in another universe where laws of physics work differently. Maybe in other dimensions, 300,000 kilometers per second is a regular velocity of a crawling snail. But here's the trouble. In a place where things are fundamentally different, you won't probably last even that single second.